Hello again, statistics students, and if you are using a TI-nSpire, then this is the video for you. We're going to talk today about how do we put in our data that has an X and a Y coordinate, an explanatory and response, into your TI-89 calculator. And then we're going to look at how do we make the scatter plot, as well as how do we do some of the other calculations, like finding the R value and stuff like that for your data set here in chapter 3. So grab those TI-nSpires. If you have your textbook, you might want to, if you want to follow along, the data set I'm using is on page 145 in your book. So if you need to, pause the video, go grab your book, grab your calculator, and get that open to page 145, and let's get ready to follow along. I'm going to switch over to the camera so you can see my calculator. And here we go. Whoops, there it turned off. All right. So I have already made my data entry page here. Hopefully you remember how to do that. If you're at your home screen, right? It's the blue one right here, not the one I'm highlighting. It's this one over here. That's the one you want. And when you get in there, that will allow you to enter data. It's really important this time, guys, to make sure that your X and Y coordinates are on the same line with each other. So you can see here, like the 120 person has a 26-pound pack, the 187-pound person has a 30-pound pack, and so on and so forth. Keep them on the same lines and keep them together, because otherwise it'll really throw off your computations later. Notice that I have labeled my lists. I've titled them at the top. I've got body for the body weight, explanatory variable column, and then I've got another one that says pack. That's the pack weight. That's the responding variable column is pack weight, and the explanatory column, of course, is body weight. So that's why I've labeled them that way. You will want to label them as well. Label them, body weight, pack weight, body pack, whatever you want to do, A and B, just so long as you can keep straight which one's the explanatory and which one's the response. First thing I want to do is make a scatter plot. So I'm going to go back to my home screen, and I'm going to go down here to the purple icon if you have the color screen. If you don't have the color screen, that's okay. School ones I know are not in color. It's the one that says add data or statistics to new document. So as you go from left to right, it's the fifth one over. Okay. And I'm going to get here, and you can see there's just some dots floating around out there. So I'm just going to move my cursor down to the x-axis, and that's where we put in the explanatory variable. So I'm going to click, and I'm going to add the body weight just over there that popped up. So I'll enter body weight, and you see body weights. And then I'm going to move the cursor over to the vertical axis, over here where it says click to add. Click there. And I'm going to add the pack weight. And ta-da, there it is. Nice, beautiful graph, just like the one we expected to see, because we had seen it in the presentation for the video from class for Thursday or Friday the 12th or the 13th. Sorry. The 5th or the 6th. Yeah, as you can see, we have the same pattern that we saw before. Looks like it's a positive linear correlation. There's that outlier point, or well, possible outlier point. We haven't really talked about how to identify that as an outlier yet. We will get to that though, so don't worry. If you haven't seen that part yet, or if you haven't gotten to that video yet, it's coming. So we will talk about that later. All right, well, so one of the things that I'm interested in is that correlation value that we talked about previously. And so I want to show you how to compute that. So what I'm going to need here is a calculator screen. So I'm going to go to the main menu again here, and I'm going to go over to the very far left one, the calculator screen. So there we go. And right here on this screen, what I'm going to do is I'm going to go to the menu button over there on the right side of the keypad, hit the menu. And I'm going to go down to statistics, which is choice number 6. And I'm going to go into my calculations, which is choice number 1. And you can see there's a whole bunch of different regression models here. Okay, there's linear regressions, there's mean, median, line, quadratic, so on and so forth. Now, quick sidebar here. So we have to take a quick timeout before we do anything else here. If we were in algebra class and I asked you, what is the equation of a line? You would probably tell me something like this, that y equals mx plus b. And you'd be right. That is a great way to define the equation of a line. Unfortunately, statisticians, well, we're a little bit different breed. So we came up with our own equation of a line. For an equation of a line in statistics, okay, we use this. This is y hat. There's actually this little hat caret thing on top of your y. And yes, we literally call it y hat. And it's equal to a plus bx. Okay, I know. Why change it up? Well, there's some reasons why, but let's not get lost in the weeds here, guys. It's still got an intercept. There's your intercept. It's still got a slope. Okay, it's the response variable now is y hat, and the explanatory variable is x. A lot of times we call this a prediction equation. Okay, so in other words, we're predicting a value for the response using an intercept and a slope that we've calculated and some explanatory variable, we call it x. Okay, so that is how we define a linear equation in statistics. All right, so I know this is your algebra, this is still a good equation of a line, it's fine. But for us going forward in statistics, we're going to be talking about A and B, not M and B. And the B is switched from being intercept to being slope. So yeah, I get it. There's some confusing things going on there. Statistics just had to be different, I guess. So when you look at your list of regression models that are possible here, you want to make sure you choose the one that says linear regression A plus BX, which is choice number 4. Okay, there we go. That way we're all talking the language of statistics. Now, the X list, okay, well, we know that that's the body weight list. So I'm going to press that there, and then I'm going to click in here, and I'm going to go with pack weight here. And I'm just hitting enter on them, guys. I know you can't see what I'm clicking on the keyboard, but that's all I'm doing. Now, this next line, save the regression equation. Well, it looks like it says save reg EQN to F1. But what we're really doing here is storing or saving the equation that it's about to generate, because it's going to generate a linear model for us. And we're just saving it to one of the functions in the calculator. So that's a really good idea. We want to keep that. So we're going to leave that. The rest of this is, we can leave it all blank. We just get down here to OK, hit enter, and boom, look at that. Linear regression equation, A plus BX. We get A, 16.265. That's the intercept. We get B, 0.0908. I'm rounding to 4 decimal places, I know. We get something called R squared, and then we get R. Now, if you're watching this early, we haven't talked about R squared yet. We're going to talk about R squared on the 16th or 17th, and depending on when you have class. And so don't worry about the R squared. Okay, we will get to it. If you're watching it after the 16th, 17th, we've already talked about R squared, and then you already know it's called the coefficient of determination, and you know what it does. But if you haven't got that yet, just ignore it for a moment. Look at the next line down. We have R. That's the correlation coefficient that we talked about in class, or in the video for class on the 12th or the 13th. It's a 79.5. I'm gonna go ahead and just say 80% because it's really close to 80%. So that tells me that's a pretty strong correlation. Okay, we have a pretty strong correlation to our graph over here. And you might be thinking, well, that doesn't look like a very strong correlation, but it is a pretty strong correlation. Now in this, okay, I'm going to, that's not what I meant to do. Back up, there we go. I'm going to go down to analyze this graph. Okay, and you can see choice number 6 here is a regression. And I'm going to have it show the A plus BX line right here as well. And so the same line that we had generated before. The only thing about this screen is it gives you the line and it graphs it on there nicely, but it doesn't tell you the R value. You actually have to do the R value on the calculator screen. there. But now you get to see, oh yeah, that data does seem to fit that line pretty well. I get it. There's these two dots out here at the end. Okay, and one of them was like, hey, why is that dude or gal or whoever who weighs 187 pounds only have a 30-pound pack? And we talked about it in the video, like why that might be. There's also this one that's up here now. You got like, well, hey, that dot's way up there. Maybe that's an outlier. Could be. Again, we will define a little bit better how we pick out outliers and which one of those would be an outlier later on in the class. So, all right, guys, there you go. That's how to find a R value, do a scatter plot, and even come up with what's called the line of best fit, the least squares regression line. It's got lots of names. But that's how we come up with a linear model to fit our bivariate data. And that's pretty much all the calculating we're going to have to do in chapter 3. I mean, there's a few other things in here. Shouldn't be too difficult, though, to figure out from all that stuff that we just did there. So again, if you want to go back through that, rewind the video, that's great. If you were like, oh man, I really wish I'd follow along, now's the time. Go grab a book. Look on page 145, get that data set, go through the video again, and I think you'll see that it's pretty easy to do on a TI-nSpire. So, all right, guys, thanks for watching. Hope you enjoyed this tutorial on how to use your calculator for chapter 3.